So the first signal f of t is delta t. What is delta t? Impulse signal. It will be something like this. Only for t equal to 0 it has the value. For other values of time it is 0. So we will try to find out the Fourier transform for this. So f of omega is equal to integral minus infinity to plus infinity. Instead of f of t I am writing delta t into e power minus j omega t dt. Okay. What is the nature of this delta t? This is valid only for t equal to 0. Okay. But this integration is with respect to t. It considers all the limits from minus infinity to plus infinity. For all the other values of t, this is 0. Only for t equal to 0, this is 1. For t equal to 0, when I substitute t equal to 0, e power 0. So this is 1. So whenever you see, okay, delta t in the time domain, its Fourier transform is 1. Okay. Second signal f of t is e power j omega naught t. See, just now we know this relationship. For delta t it is 1. So can I write like this? Shall we write like this? Listen here. Inverse Fourier transform of 1 is delta t. Shall we write like this? Okay. So we know the inverse Fourier transform equation. What is the inverse Fourier transform equation? 1 by 2 pi integral minus infinity to plus infinity. F of omega is 1. E power j omega t dt or d omega. Okay. Is it correct? So can I write like this? 2 pi into delta t is integral minus infinity to plus infinity e power j omega t d omega. Okay. So now we will apply change of variables. You just change t to omega and omega to t. So left hand side it is 2 pi delta omega. Right hand side it is integral minus infinity to plus infinity e power j. So omega and t if you interchange also, this term will not change. d omega will become dt. We will have this result. This result we are going to use. What is the question actually? Fourier transform of e power j omega naught t. So now let me use the formula integral minus infinity to plus infinity. Instead of f of t, I am writing e power j omega naught t into e power minus j omega t dt. Is that right? So let me combine these two exponentials. Integral minus infinity to plus infinity e power j omega naught minus omega into t dt. Now we just compare this equation. Right hand side integral minus infinity to plus infinity e power j omega t dt. If there is e power j omega t, left hand side I am just writing 2 pi into delta omega. This is also in the same format. Integral minus infinity to plus infinity e power j omega naught minus omega into t dt. So can I write this something like 2 pi delta omega naught minus omega. Okay. Now another one more step. 2 pi delta, let me take minus common. In Fourier series, we discussed one condition. If f of minus t is equal to f of t, this condition holds good for even signals. What do you mean by even signal? If the signal and its mirror image looking same, that's called even signal. What about this signal? Impulse signal is a even signal. So can I write this is something like f of minus t that is equal to f of t. So can I write like this? So this is the result. So you can write this is a even signal. Then third problem, f of t is equal to e power minus j omega naught t. So since we have derived, in the same way you can derive and you can produce the result something like this. F of e power minus j omega naught t is equal to 2 pi. If there is a plus here I am getting omega minus omega naught. Here there is a minus. So you can use the same procedure and you can get the result. Next one, f of t is cosine omega naught t. Say I don't want to substitute this cosine omega naught t in the Fourier transform, forward Fourier transform equation. Instead, I am using the earlier results. Okay. So, using Euler's identity, you can write this cosine omega naught t something like this, e power j omega naught t plus e power minus j omega naught t divided by 2. Okay, Euler's identity. So now you apply Fourier transform for this entire equation. So left hand side f of t will become f of omega. This 1 by 2 is constant. So Fourier transform is basically a linear transform. If I apply Fourier transform for the left hand side, then I need to apply for each and every term what is there in the right hand side. So it's nothing but f of e power j omega naught t plus f of e power minus j omega naught. So do you have the result for this f of Fourier transform of e power j omega naught t and Fourier transform of e power minus j omega naught t? Just now example 2 and 3 we got the results for this. So directly I am just using the results 1 by 2. For the first term it is 2 pi delta omega minus omega naught. Second term 2 pi delta omega plus omega naught. So you can cancel the 2 and you can take pi common. So the answer is pi into delta omega minus omega naught plus pi into delta omega, pi I have taken common. This is Fourier transform of cosine omega naught t.